Hi, my name is Michael Weinberg, and today I'm going to talk about a problem that every team faces. How do you thoroughly test changes in a real environment before you ship them to customers in production? A little about me. I'm an engineering leader who specializes in cloud-native technologies, developer productivity, and reducing friction in the software development lifecycle. For the past 5 years, I've led a variety of platform teams. Prior to that, I consulted for several years, working with everyone from one-person startups to Fortune 5 companies. I've used HashiCorp products as critical tools in my workflow for the last 12 years. Today, I'm focusing on a specific common pattern for testing changes called review apps. For our purposes, review apps are internally accessible, independently addressable instances of a service used to validate changes to an application before releasing it. To further define a couple of those terms, by internally accessible, I mean that the review app is available beyond a developer's workstation to other members of an organization. It could also be publicly accessible if that's appropriate for the use case. Independently addressable means that a user can hit the review app separately from a stable instance of the service and vice versa. You can contrast this with canaries, where you're splitting traffic between a new and an old version of the service, and you don't necessarily know which one you're going to get. As I said, review apps are a common pattern. You may already be familiar with some of the public offerings for these: Heroku review apps, Vercel preview apps, AWS feature branch deploys. All of these are the same basic pattern. Let's walk through a really simple example. Here's about the smallest microservice architecture that you could have. We've got a front-end application speaking to a back-end application speaking to a database. In this slide, each of these applications is deployed from the stable code in the main branch. With a review app, a developer working on the front end in a branch called dev deploys a review app. That application runs parallel to the original instance of the front end, and it is accessible at its own URL for validation by the developer and others in the organization. Both instances of the front end communicate to the same stable instance of the back end application. Then another developer working on the front end in a branch called feature deploys a review app. It runs alongside the other two and also communicates with that stable instance of the back end deployed from the main branch. Later, a developer working on the back end service in a branch called feature deploys a review app of the back end. That runs parallel to the stable instance of back end, and it communicates to the same database. It doesn't receive any traffic from any instance of front end. At this point, a limitation with microservices and review apps is hopefully apparent. The same properties that make them great for isolated testing of changes to a single service make it more difficult to test changes across services. We're going to come back to this in a minute. My clicker, there we go, okay. Obviously, the prior example was really simple. As microservice architectures scale, they tend to look more like this one, with many more backend services than front ends. This is where the isolated nature of review apps becomes a challenge. As the microservice architecture dependency tree grows, less and less of the system is actually testable via review apps. In this example, it is only possible to perform end-to-end review app tests with 2 of the 8 services. Of course, there are some ways to test backend services, but they present some drawbacks. Let's take a look at this. The first option is to just claim the entire environment for testing purposes. We can deploy code from feature branches to a shared environment in place of the mainline instances. Here, we have 6 services that are running from the mainline and 2 that are running from development branches. This allows us to test changes to several services and in any permutation we need, but it comes with the risk of disrupting the environment for others. At best, other users are going to receive unexpected results from those backends that are under development, and at worst, you might break the environment entirely. This option generally works okay for smaller teams and fewer services, but as teams grow, the impact of breaking a shared environment increases. Assuming an average of 3 developers per service, in this scenario, a single broken review app could sideline 24 developers. As teams scale, they may be able to extend the viability of this approach by adding several review environments with some sort of a system for reserving them. Eventually, though, cost and complexity will become serious challenges to this approach. A second option, which is a bit more agile, is chaining review apps. With this approach, teams use review apps to provision all the services they need to test a change. In this example, the circled review apps have actual code changes, and the other 3 review apps only have configuration changes to point to those review apps. This approach improves on the first option by isolating one developer or team's changes from the rest of the organization. It is also less expensive than spinning up several complete review environments. There are still several drawbacks, though. With this approach, developers need to be aware of the full dependency tree in front of their services, so for all the downstream services that they need to reach their application. They also need to make configuration changes across all those repos, or all those code bases, to deploy those multiple services, and they may not work those regularly. The added overhead and cognitive load often means that review apps used this way will only be used for major changes or extended testing, and they will not be used for short changes. So you're actively discouraging developers from using review apps to test most of their changes. The ideal approach would be one that only requires deploying review apps for the specific services that have changed, like in option 1, but which isolates those review apps from the stable environment, like in option 2. Most users of the environment would route to the stable versions of services deployed from main. Users who are actively testing one or more review apps would route to those apps while being able to rely on the stable versions of every other service. This would require the ability to selectively route to review apps anywhere in the dependency tree, along with the way to decorate requests to indicate that we should route to review apps. Now we have a user story. As a developer, I would like to route through specific review apps anywhere in the stack without adjusting dependency references so that I can test changes that span several services without impacting other users. We can build a list of requirements for our solution. 1, we should be able to select review apps by decorating a request so users don't need to configure anything else. 2, no changes should be required to download downstream services to route to review apps. And 3, anywhere we don't request a review app, we should automatically use the stable version. I discussed this challenge with a former colleague, and we decided we could probably solve this using Consul Service Mesh. 1, we could use HTTP request headers to decorate requests that should route to review apps. 2, we could use Consul Service router entries to route to review apps based on the supplied headers. And 3, we could use Consul Service resolvers to distinguish between the stable version and the review apps for a service. In order to implement this, we're going to rely on a few conventions. The first is header forwarding. Our platform will expect every application to forward specific company headers it receives to upstream requests. These headers allow us to share request context between applications in a consistent manner. For demo purposes, we're forwarding all headers that start with xacme. Our second convention is that all review apps are deployed to Kubernetes namespaces prefixed with review. In order to have a consistent namespaces, we're using review followed by the Git branch. And our final convention is that application containers are built on every push to GitHub, and they're tagged by the Git commit SHA. With these 3 conventions in place, we can implement routing to one or more review apps anywhere in the stack. Now, I'm going to provide a little demo showing this is possible. The Kubernetes setup for this demo is very simple. I've provisioned a cluster on my laptop using Kind and followed the tutorial on the Consul website to install Consul with the Kubernetes integration via Consul K8s. To make the demo app easier to access, I'm using the ngrok ingress controller. I've also installed Kyverno, which I'm using as a basic mutating admission controller to automate the configuration necessary for the review app routing. For demonstration purposes, I'm manually deploying so that we can see the system change. A little more about Kyverno. Kyverno is a policy engine that has built-in mutation features. It is doing 3 things for all deployments in a namespace with the review prefix. The first mutation is adding 2 annotations to application pods to dynamically add Consul service meta keys. The meta keys we're adding are namespace, which is the Kubernetes namespace, for example, review awesome feature, and version, which is the Git commit SHA. If you're already familiar with Consul and Kubernetes, you might be wondering why we don't just use the existing K8s namespace service meta entry. The reason we're not using that is that the filter we need for the service resolvers doesn't allow dashes in the key. The second mutation that we're applying is to add the Consul service resolver subsets to each of the review apps resolver resources. We're adding 2 resolvers, one to track the namespace and one to track the version. And the third mutation is adding the service router entries with matching based on the 2 host headers, X Acme review namespace and X Acme service name version. And that's going to allow us to route to specific review apps based on their version or a whole set of review apps based on a shared namespace. Meet Beppo. This is Beppo, the owner of Beppo's Bottle Shop. Beppo's dream is to build the best online specialty store for non-alcoholic beverages. To do this, he's investing heavily in technology and has adopted a microservices architecture that lets his product teams ship changes quickly and independently. There are currently 4 services: a React front end, an API that provides the data for the front end and may service third-party integrations in the future, and a catalog service that contains product information. An inventory service that tracks and manages Beppo's product inventory. Beppo has many developers working to make this vision a reality. Those developers are divided into 3 teams, each focused on a specific aspect of the product experience. Each of these teams owns one backend service, and they all contribute code to the front end as needed. The core experience team owns the overall site experience and partner integration APIs. The catalog team owns product discovery and information, and the inventory team owns inventory tracking and management. With this context, let's look at the catalog team's experience adding a new feature to the site. The catalog team sees an opportunity to improve the shopping experience by adding product descriptions to the site. Even though customers are generally familiar with the products that they like, they feel they can drive more sales with engaging descriptions that remind customers why they like specific products. This change requires an update to the catalog API to include description data and an update to the front end to display the descriptions. The API is simply aggregating data from its upstreams, so it doesn't need to be updated to pass along new description data. Because the new descriptions will be the largest blocks of text on the page, the team wants to see their changes in action before shipping them to customers. They're also excited to show them to Beppo to get his feedback. They'll use review apps for the front end and catalog services to share their changes internally before releasing them to customers. In this pre-recorded demo, we'll see how Consul is reconfigured when review apps are deployed and see the routing working in action. First, we'll see the initial state of the cluster, then we'll deploy the front end and catalog review apps and route to them using headers. So here's the stable version of the site before we've added any product descriptions. It's very simple. We click on a product, and we'll see a little more information about it, how large it is, how many are in stock. There's also an API exposed, so we can see here the catalog information and inventory information that comes back from the API, and that's the same information that populates that product page. Now we'll take a look at what's running in Kubernetes behind this. So first we see the pods. There's just 4 application pods running right now, 1 for each service. The rest of what's running in Kubernetes is the Consul control plane and server, the Kyverno pods, and the ingress controller, which is making it easier to reach the services. Taking a look at what we have in Consul, you can see the topology for the ingress controller. It is routing to the front end or the API directly based on the path prefix. So here's the config for that. So if we get something for /API or /API/, we're going to route that to the API directly. Everything else is going to route directly to the front end service. And you can see here from the API topology, the same thing. Those are routing to the API, and then the API is routing to both the catalog and inventory services. We'll also take a look at the actual routes that are in place for the front end service here. So right now, everything is routing to a default subset for the front end resolver. And if we take a look at the code for the resolvers, each application has this default defined, and the default is basically defined as anything that does not match the review prefix for the namespace meta key is going to be in the default subset for the services. So that's going to be consistent across all 4 of the services. That's the only config that we're starting with. The second thing we'll look at here is the router configuration. So the only routes we have defined currently are for the API service, and all they're doing is stripping out the API prefix so that traffic that comes in from that ingress controller to the API endpoint gets renamed to just be / from the API's perspective. All the other services have empty routes. There's nothing configured in Consul for those right now. And those will be reconfigured when we do our review app deploys. We can also look at these from the Kubernetes perspective. So we'll pull up the resource definitions that we have in Kubernetes for both the service resolvers, service routers. So first, the service resolvers. And you see here that we just have that one subset defined for the service resolver. We can look at the service routers, and there it's empty. There's nothing defined. We've just registered that resource so that we can mutate it later or patch it later. And we can see the same thing looking at Consul directly. There's nothing defined for the catalog. And we look at the front end, it's going to be the same story, nothing defined there. So I don't have any routes hidden up my sleeve. It's all going to happen when we do the deploys. Now we're going to take a look at the PR for the description changes. Pretty simple PR. We have an update to the catalog service to add descriptions to the API response and to include those descriptions because right now all of the product information is just hard-coded in the demo app. And then we have some styling changes to style the descriptions the way we want. Makes a couple other changes to the product page. And finally, we have the product page itself, adding the description field to it and moving a couple other things around so that it looks nicer. So we jumped ahead just a tiny bit. I created a namespace. I'm deploying the front end and the catalog applications into that namespace. The namespace is review product descriptions to match the convention we're using. And to make, for the demo purposes, I'm using M substitute to just inject the commit SHA as the Docker tag for these. So now that we've deployed those services and seen that the pods are running, we can now see that the routes are in place and we have the resolvers. There's a route for tracking the namespace, and that goes to a resolver that tracks the namespace. And then we have a route for each application's version, and that's going to go to a resolver that tracks that version number. We'll see the same thing is in place for the catalog. Here. And we can also see these by looking at Kubernetes, see that these were created or present in the resource definitions in Kubernetes. So we'll first take a look at the service. This is the service router. And you see we're matching on those headers, just like we see in the UI. And now we'll see this in action. So I've got a Chrome extension here that lets me inject headers in the requests. So the first one we're going to do is inject the review product descriptions header or value to the X-Acme review namespace. Save that. Now if we click on a product, we're going to get descriptions. There's the description. We can also see that this is present in the API response. And again, the API was not modified for this. And we can also access these by selecting the version numbers, so we can go app by app. So no change there, exactly the same behavior. We can remove one of those, so now we'll get the styling changes without getting the catalog data. And they're there. And we can do the inverse, or we can just turn them off entirely, and we'll get back to the original design. We can do just the catalog. And here, there's obviously no change to the product page because we don't have any of the front-end pieces, but we can look at the API response. And we will see that the product description is present in the API response. And if we refresh without that, we will not have the description in the API response. Going back to the original state, turn it on once more just for fun. There's the styling on the main page. And we can click into a product page again, and there's our description. So we'll take a look now at the mutation rules that we're actually using here. They're pretty simple. The first one, these all apply only to things that are deployed to the review namespace. The first one is adding 2 annotations to those pods by mutating the deployment object. So the first annotation is the namespace as a service meta key, and the second one is the version as a service meta key. And those are both pulled from the actual the spec that's being deployed. And if we look in here, this is the original instance that comes from stable, so this does not have those meta keys present. And we'll look at the other instance as well and see those keys there. There's the namespace, and there's the version at the bottom. And like I said, the reason we don't use that Kate's namespace is that the service resolver queries don't like having hyphens in the key name. They're fine with them in the description, in the value, but it doesn't work well in the key. Now we will look at the next mutation. This one is adding the service resolvers. So here, again, only applies to the review namespaces. We are patching the existing Consul service resolver entry for each of the apps with 2 values. One is a subset based on the namespace, and another is a subset based on the version. These are not visible in the Consul UI directly, so we will take a look at them from the command line. So there's the catalog, and you see, in addition to that default it started with, and how it has the review with the commit SHA and the review product descriptions, which tracks the namespace. And finally, we have the service routes. So this is patching the service router for each application, and we're, again, injecting 2 routes to that. The first one is going to track the namespace. The other one's going to track the version number, and those will allow you to route to those subsets that we created in the prior mutation based on the HTTP headers for the namespace and for the service version. And we'll look at those via the command line as well. Pardon the typo here. Pardon the second typo. It's too deep in the demo to re-record the whole thing. There we go. So we have the, what was previously empty now has those routes matching those HTTP headers. And that is it for the demo. So to review what we just did, we deployed review apps to 2 services, front-end and catalog. We used Consul service resolver and service router entries to enable header-based routing to those review apps. And we demonstrated routing between those review apps via a third app, API, that did not have a review app at all. So in closing, I'd like to leave you with a few ideas for how you might extend this pattern to add more value to internal platforms. The first is to use reverse proxy, API gateway, layer 7 load balancer, some sort of edge component to map subdomains to headers to create just-in-time ephemeral environments. This would allow users to view review apps without needing to do any sort of manipulation client side. Taking the demo as an example, we can have a request to review product descriptions.consulreviewapps.ngrok.io, automatically inject the xreview namespace header set to review product descriptions for all requests. And then that URL would just be available for people to route to whatever review apps were present in that namespace. In a similar vein, we could create long-running partner integration testing environments or other testing environments by configuring an edge component to inject the headers for each application version that should be present in that environment. And this would allow technical program managers or other project leads to coordinate testing across several services and several teams without needing to centralize the configuration for that or the development work. And the third thing is that since Consul offers such a robust API, we could enhance the developer experience working with review apps by providing a browser plugin for selecting versions based on the data that's in Consul for those services. This would allow users to independently identify and select the review apps that they want to route to. I hope that this talk inspired you. If you're interested in talking more about this, please find me in the hallway, at the reception. And if you want to try it out yourself, all of the code is in my GitHub. It's github.com/luckymike. And then this is Consul Review Apps. Thank you very much.